Good morning, dear students. Today we are going to start with the new system, that is the reproductive system. So we are going to deal with the functional anatomy of the male reproductive system in today's class. So the briefing of the reproductive system has been done in the last class, in yesterday's class, and to some extent you might have discussed about the sex determination and the sex differentiation also in the yesterday's class. So moving ahead with the male reproductive system today, so we are going to start with it. So the male reproductive system, if you see, you got a pair of testes. So testis, T-E-S-T-I-S is the singular and the plural is T-E-S-T-E-S. Coming to the reproductive organs in the males, we classify into two things. One is the primary sex organs and the second one is the accessory sex organs. The primary sex organs in males is a pair of testes. Whereas when you come to the accessory sex organs, it includes seminal vesicles, a prostate gland, urethra and penis. So by this you have come to know that the male reproductive system, it is divided into two things. One is the primary sex organs, which includes a pair of testes, and then you have the accessory sex organs, which includes the seminal vesicles, the prostate gland, the urethra and the penis. Moving ahead, again, as far as the genitalia is concerned in the males, you can divide into two things. One is the external genitalia and the second one is internal genitalia. So in males, the external genitalia or the genital organs, it includes the scrotum, in which rests the testis, then there is penis and the urethra. So these three things, they constitute the external genital organs in males. So remaining whichever is there, they are considered as the internal genitalia. So this is about the external and the internal genital organs in the males. Now let's see in detail about the testis, the functional anatomy of the testis. Remember, the singular is T-E-S-T-I-S and the plural is T-E-S-T-E-S. So whenever you are talking about a single gonad of male, it has to be T-E-S-T-I-S, and whenever you are talking about a pair, it becomes T-E-S-T-E-S, because it's a common mistake which the students usually do. Not only the students, even sometimes we also tend to make this mistake. So I am stressing on this point. So the last two letters IS is for singular and ES is for plural. Okay, now moving ahead to the functional anatomy of this testis. Testis, it's a ovoid or a walnut shaped body, and it is located and suspended in a sac like structure called as a scrotum. So scrotum is the external genitalia. So inside that you have the internal genitalia of the male, that is the testis. And each testis, it weighs about 15 to 19 grams and it measures about 5 centimeter into 3 centimeter. So that is about the measurement of the testis. And inside each testis, there are about 900 coiled tubules, which are known as the seminiferous tubules. And in these seminiferous tubules, the sperms are produced, and these seminiferous tubules, which are the coil-like structures, these are present inside the lobules of the testis, and these seminiferous tubules coming out of the lobules of the testis, so they join together in the mediastinum of the testis, where it is the retitestis, and from the retitestis arises the further portion that is called as vas efferens. I repeat once again, it is vas efferens, starts from E, vas efferens, and about 6 to 8 vas efferens are present, which join together and they form the epididymis. And this epididymis, so it has got a head, it has got a body and a tail. So 3 portions are there in the epididymis. It is the head, body and the tail. So the tail of the epididymis, it continues as vas deferens. I repeat once again, it is vas deferens, starts from D. Now this vas deferens, now what happens is, it extends upwards and it moves into the abdominal cavity via the inguinal canal. So what is happening? You got the seminiferous tubules inside the testis, and from the seminiferous tubules they converge into the mediastinum of the testis, where the portion is called as the retitestis, where the convergence of all the tubules, the seminiferous tubules, is occurring, and from there it arises around 6 to 8 vas efferens, and these vas efferens, they join to form the epididymis, which continues from the head to the body of the epididymis, then comes to the tail of the epididymis, which continues as vas deferens, and it ascends upwards and enters into the abdominal cavity via the inguinal canal. So once it goes into the inguinal canal, through the inguinal canal into the abdominal cavity, so it finally terminates, and the terminal portion of this vas deferens is called as the ampulla, and it is going to finally join the duct of the accessory male reproductive organ, that is the seminal vesicle, on the same side. So what will happen is, the ampulla, that is a terminal portion of the epididymis, it is going to join with the duct of the seminal vesicle of the same side to form ejaculatory duct, which again opens into the urethra. So this is the whole story of this beginning of the seminiferous tubules, and finally it is ending into the male urethra. So this is a diagram. In this, the things are very clear. You can see the testis in golden yellow color. Then on that, a snail-like structure is present. That is the head of the epididymis, which you can see. Then it narrows, which is the body. Further narrows in the lower portion of the testis, that is the tail of the epididymis. And then there is a sharp U-turn. That is the beginning of the vas deferens, which you see it is ascending upwards very nicely, and it is entering into the abdominal cavity through the inguinal canal, and finally it goes and it joins with the duct of the seminal vesicle on the same side, which is depicted in green color, which you can see, and once those two ducts join together, it forms a common ejaculatory duct which is coming out of the seminal vesicle. You can see in the diagram, and finally it is going to open into the urethra. The the urethra. It is going to open into the urethra. So we can see clearly the things in this diagram about the testis, the epididymis, the vas deferens joining with the ducts of the seminal vesicle, forming the ejaculatory duct and opening into the urethra. The things are clear till here, I feel. Now let's move ahead. Coming to the coverings of the testis. So as we are dealing with the functional anatomy of the male reproductive system, so we are concentrating more on the main primary sex organ, that is the testis. So we are dealing with what is there inside the testis, what are the coverings of the testis, what are the cells present inside the testis, and what is the function of those cells. That is what we are going to discuss in today's class, and we are doing that. So moving ahead, coming to the coverings of the testis. So you got three covering from inside to outside. The innermost is tunica vasculosa, followed by tunica albuginea, which is the middle layer, and the innermost layer is tunica vaginalis. So outermost layer, I'm sorry, it is the outermost layer, that is the tunica vaginalis. So I repeat once again, from inside to outside, you got the three coverings of the testis. First is the innermost tunica vasculosa, second is the tunica albuginea, which is the middle layer, and the outermost layer is tunica vaginalis. Coming to the innermost layer, the first layer, name is the tunica vasculosa. This is having, as the name itself suggests, vasculosa. So there is rich blood supply here. This is made up of connective tissue, and there is rich blood supplied by rich blood vessels, as the name suggests. Coming to the second layer, which is the middle layer or the middle covering, you can say, it is tunica albuginea. It is a dense fibrous capsule, gives protection. Coming to the third layer, tunica vaginalis. So this tunica vaginalis, it is the outermost closed cleft-like covering, and it is formed by mesothelial cells. So points to be noted here. So it is a outermost closed cleft-like covering, and this is formed by mesothelial cells. This to be underlined, mesothelial cells. And this tunica vaginalis is again made up of two layers, outer parietal layer and inner visceral layer. So outer parietal layer and inner visceral layer. So these two layers, they glide on one another, and that allows the free movement of the testis. Now coming to the different layers of this tunica vaginalis, let's talk about the visceral layer, the inner visceral layer. So this inner visceral layer, it is adhering to the tunica albuginea. So it is adhering to the tunica albuginea, whereas the outer parietal layer, so it lines the inner surface of the scrotum. So outer parietal layer is in close contact with the inner surface of scrotum, whereas the inner visceral layer, it is adhering to the tunica albuginea. So these two layers, so they glide on one another and allow the free movement of the scrotum. Now this tunica vaginalis, it is going to cover only the anterior and the lateral aspects of the testis. Anterior and the lateral aspects of the testis. The reason is the posterior surface, there is mediastinum, the mediastinum of the testis. As a result, this tunica vaginalis, it is not going to cover the posterior surface of the testis. Okay, so it is going to only cover the anterior and the lateral surfaces. Is it clear? Okay. Let's move ahead to the parenchyma of the testis. So diagram clearly depicts all the things which are there. So you can start with the triangular shaped lobules. We got many lobules inside the testis. That is formed by the septula testis, which we will study in front. Then you have got the seminiferous tubules, which are coil-like structures present inside the lobules of the testis. Then you have got the resti testis, that is the area where all the seminiferous tubules come and converge, which is present in the mediastinum testis. Followed by vas efferents. So from the reti testis arises about 6 to 8 vas efferents, which are going to join together to form the epididymis. And then you all know about, just now we had discussed about the epididymis. So the epididymis is having again 3 portions: head, body and the tail. And the tail portion further goes to the next part, that is the vas deferens. And then you got interstitial cells of Leydig in the testis. So this is about the structures which we need to deal with, the parenchyma of the testis. So what are the structures we need to deal with? It starts with the lobules of the testis, seminiferous tubules, reti testis, vas efferens, epididymis, vas deferens and interstitial cells of Leydig. Now let's see something a little bit about each of these things. Start with the lobules of the testis. Now how these lobules are formed, and so this we just now discussed that there are 3 layers of coverings, or 3 coverings which are covering the testis, and we even discussed that the innermost layer is absent. So outermost layer is absent in the posterior portion. The outermost layer was tunica vaginalis, whereas this tunica albuginea is present in all the 3 portions of the testis: anterior, lateral and the posterior surface. Now what is this tunica albuginea doing in the posterior surface? So in the posterior surface of the testis, tunica albuginea is thickened to form mediastinum testis. So you all remember reti testis is present in this mediastinum of the testis. Now from this mediastinum of the testis, the connective tissue septate called as septula testis. So underline this word, septula testis. This radiates into the testis and binds with the tunica albuginea at various points, and as a result of this, the testis is divided into a number of pyramidal lobules. These are called as the lobules of the testis. And if you see the diagram, the base of the lobule of testis, it is directed towards the periphery. It is directed towards the periphery, and the apex of each lobule, if you can see in the diagram, it is directed towards the mediastinum of the testis. So repeat once again. The testis is divided by the reti testis into various lobules of the testis, and each lobule of the testis, the base is directed towards the periphery and the apex is directed towards the mediastinum, right? And each testis, it has about 200 to 300 lobules. It has about 200 to 300 lobules. And the point to note here is the septular testis is not going to form a complete partition. It is not going to form, it is not like every lobule of the testis is separate. It is not like that. The lobules of the testis, they are going to anastomose with one another. It has to anastomose with one another. So in the diagram you can clearly see that they are not separate structures. The lobules of the testis, it is not like divided like separate. No, there is connection. Anastomosis is present. Moving ahead to the seminiferous tubules. So each lobule of the testis, it contains about 1 to 4 coiled tubules, and these are called as seminiferous tubules. And these seminiferous tubules are surrounded and supported by interlobular connective tissue. It is not like they are completely tightly attached with each other. There is a gap, and it is with the help of this, and it is supported, and it is surrounded and supported by the interlobular connective tissue. And these seminiferous tubules, they do not end bluntly, but they form a single, double or triple arches, and that is going to end in the mediastinum testis. So the limb of an arch are not in the same lobule, it is different. It is going to be different. Now coming to retitestis. So retitestis is present in the mediastinum testis. And what it is? It is a network of thin-walled channels. It is a network of thin-walled channels, and all these seminiferous tubules, they finally open in the retitestis. So remember here, mediastinum testis is present in the posterior portion of the testis, right? And here retitestis is present. The seminiferous tubules will come and they will end in the retitestis. So that's about the retitestis. Next, about vas efferens. So from the retitestis, vas efferens is going to arise. So this vas efferens, finally what will happen? They are going to join together and form the head of the epididymis. The head of the epididymis, and they converge to form the duct of the epididymis. So that's about the vas efferens. Coming to the epididymis. So epididymis, it begins at the head, where it receives the vas efferens. With all the vas efferens, they converge, okay, and they form this epididymis. And coming to the duct of the epididymis, it is enormously convoluted tubule with a length of about 4 meters. So if you elongate it, if you completely make it elongated and measure, it's almost about 4 meters. I repeat, it's 4 meters, not 4 millimeters. It is 4 meters. So you can just think about how much long it is, right? But it's so small when it is completely packed. So it is a convoluted tubule. That's why you just it's so small structure, but when it is elongated completely, it's about 4 meters long. So epididymis has got 3 parts, you all know by now. It is the head of the epididymis, the body of the epididymis, and the tail of the epididymis. That continues as the next portion, that is the vas deferens. So at the caudal pole of the testis, epididymis takes a sharp U-turn and it continues as vas deferens without any demarcation. The last portion of the parenchyma of the testis is the interstitial cells of Leydig. So these interstitial cells of Leydig, this can be asked as a viva question. In the viva they may ask you this. What are interstitial cells of Leydig? Where are they present and what is their function? So the answer to all my questions is there in this, the interstitial cells of Leydig. They are the hormone secreting cells of testis, and they are lying in between the seminiferous tubules. Is it clear? So the interstitial cells of Leydig are the hormone secreting cells of the testis present in between the seminiferous tubules. Let's see a little more detail about seminiferous tubules, because this can come as a 3 marks question for you people. Seminiferous tubules. So seminiferous tubules are thread-like convoluted tubular structures which produce the spermatozoa or the sperms. Now you may ask, how many of these seminiferous tubules are present in each testis? There are about 400 to 600. There are about 400 to 600 seminiferous tubules in each testis. So if you join together both the testis, it accounts to about 800 to 1200 seminiferous tubules. And in these seminiferous tubules, the sperms are produced. Coming to the length. So the length of each seminiferous tubule is about 30 to 70 centimeters whereas the epidermis is 400. The duct, if you take 4 meters, it is about 4 meters. Here each tubule of the each seminiferous tubule, it is about 30 to 70 centimeter long, and the diameter is about 150 to 300 microns. Coming to the wall of the seminiferous tubule. So the wall of the seminiferous tubule, it is formed by 3 layers. The outer capsule or the tunica propria, which is formed by fibroelastic connective tissue. The second layer being the thin homogeneous basement membrane, on which the third part of the seminiferous tubule rests, that is the complex stratified epithelium. Complex stratified epithelium, which again consists of 2 types of cells. It consists of 2 types of cells. One is the germ cells or the spermatogenic cells, which are going to enter into the process of spermatogenesis, and finally the sperms are released from the seminiferous tubules. The second is the Sertoli cells or the supporting cells, which are providing the support nourishment to the developing spermatozoa until it is completely developed into sperms and finally it is released. So they get detached from the Sertoli cells once they are completely matured and ready to be sent into the seminiferous tubules. So let's talk or discuss something about the 2 different cells which are present in the seminiferous tubules. So 2 cells are spermatogenic cells or the germ cells, and second one is the Sertoli cells or the supporting cells. Now coming to the spermatogenic cells, so these are precursors. These are the precursors of the spermatozoa. These are present in the seminiferous tubules, and these cells, they lie in between the Sertoli cells and they are arranged in a proper orderly manner in layers. About 4 to 8 layers of these spermatogenic cells are present in the seminiferous tubule, in the seminiferous tubules. Now in the children, what happens? The testis is not fully developed, okay, and hence these spermatogenic cells, they are also present in the primitive stage called as spermatogonia, and once this child enters in, or he reaches the puberty, so at that time these spermatogonia, which are the primitive cells, they develop into the sperms through various stages of the spermatogenesis, and finally the sperms are going to be formed. Now coming to what are the stages of these spermatogenic cells. So from the periphery to the lumen of the seminiferous tubules, if you see, I repeat once again, it is from the periphery of the seminiferous tubule towards the lumen. So lumen, what happens is the mature sperms are thrown into the lumen of the seminiferous tubules. So by this you should understand that nearing to the lumen, more matured stage of a sperm should be there. So as a result, what is happening? Towards or nearing to the mediastinum, you have the spermatid. After that, you have got secondary spermatid. After that, you have got primary spermatocyte, and finally, it is the spermatogonium, which is present near to the periphery of the seminiferous tubule. So spermatogonium goes to the primary spermatocyte stage, then it goes to the secondary spermatocyte stage, then it goes to the spermatids, and spermatids will develop into mature sperms released into the lumen of the seminiferous tubule. So by this you should understand that the more matured portion or the more matured cell as far as the spermatogenic cell is concerned is present towards the lumen. So this flow chart, it easily we can summarize, right? So starts from the seminiferous tubules inside the testis, then the seminiferous tubules are going to end in the retitestis, and from the retitestis vas efferents around 8 to 10 arise, which convolute to form the head of the epidermis. This head of the epidermis, it continues as a duct, and finally it ends in the vas deferens. The vas deferens, it enters into the abdominal cavity. The abdominal portion is the ampulla, which joins with the duct of the seminal vesicle of the same side to form ejaculatory duct, and finally it opens into the urethra. Okay, so this is about this one, seminiferous tubules, and finally ending into the urethra. Now let's discuss about Sertoli cells. So we discussed about the spermatogenic cells. Let's discuss about the Sertoli cells. This is also one of the favorite question of the examiners as far as the exams are concerned. So it can be a 3 marks short answer for you people. It can be a theory viva question, right? So quite important topic as far as the male reproductive system is concerned. They can ask you just Sertoli cells. It can be a 3 marks question. Functions of Sertoli cells is again a very favorite question. So that we'll deal in the next slide. Now coming to this Sertoli cells, the other name to confuse you in the exam, they may ask you what are sustentacular cells, or what are the nurse cells as far as male reproductive system is concerned. So the answer should be Sertoli cells. Your answer is going to be Sertoli cells. So what are these Sertoli cells? They are the supporting cells for the spermatogenic cells in the seminiferous tubules, and these cells, they are tall irregular columnar cells which are extending from the basement membrane to the lumen of seminiferous tubules. And the spermatogenic cells or the germ cells which are there, these are attached to these Sertoli cells. These are, so remember, the spermatogenic cells or the germ cells, they are attached to these Sertoli cells until those spermatogenic cells are completely matured into sperms. Only then they will detach. Until then they are attached to these Sertoli cells, and this attachment is by means of cytoplasmic connection, right? Now coming to what are the functions of these Sertoli cells. Just now I was discussing that it is one of very favorite questions as far as male reproductive system is concerned, 3 marks question. So what are the functions of Sertoli cells? First and foremost, as the name, other name of the Sertoli cell suggests, that is the supporting cell. It is called a supporting cell. So it supports and it nourishes the spermatogenic cells till the spermatozoa are finally released from these Sertoli cells into the lumen of the seminiferous tubules. That is the first and important function of Sertoli cells. Coming to the second function, Sertoli cells, they secrete an enzyme called as aromatase, and this aromatase, the function is it helps in the conversion of androgens into estrogen. Remember, estrogen hormone is not just present only in females. Some amount is also required and is present in males also. Okay, so you have to just remove that thing that male contain only testosterone and females contain only estrogen. It's not like that. Even in case of male, some amount of estrogen is present, and this estrogen is coming from the androgens, and the aromatase enzyme which is being released from the Sertoli cells is helping in the conversion of androgens into estrogen. Coming to the third function, the Sertoli cells, they secrete a protein, that is androgen binding protein. And this androgen binding protein, why it is required? It is required for the testosterone activity. It is essential for the testosterone to show its activity, right? So this is also being secreted from the Sertoli cells, and this secretion of the androgen binding protein. It is very essential for the testosterone activity, and this testosterone activity is especially, it is very much required during the process of spermatogenesis, because spermatogenesis it happens under the influence and action of testosterone. Testosterone, if there is deficiency, definitely the spermatogenesis is going to be affected. Moving ahead to the fourth function, it secretes estrogen binding protein. How it is secreting the androgen binding protein, at the same time it is also secreting estrogen binding protein. Next, the fifth function, it secretes inhibin. It secretes inhibin, and this inhibin, it inhibits the release of follicle stimulating hormone from anterior pituitary. So it secretes this inhibin in little portions. Coming to the next function, it secretes the hormone which has got opposite action of inhibin, that is activin. That is activin. So activin, automatically what it has to do? It has to increase the follicle stimulating hormone release from anterior pituitary. The next function, Sertoli cells, it secretes MRF, not MRF tigers, it is Mullerian regression factor. It is Mullerian regression factor in the fetal testis. And what is the purpose of this Mullerian regression factor? It is responsible for regression of Mullerian duct during the sex differentiation in the fetus. So what is the Mullerian regression factor doing? It is causing the regression of the Mullerian duct during the sex differentiation in fetus. This you might have discussed in yesterday's class, and hence this determines male or female. Okay. So just a recap of the functions of the Sertoli cells. So here mainly it is the supporting and the nourishment of the spermatogenic cells or the germ cells until they are completely developed into sperms and released into the lumen of the seminiferous tubules. Then it is more of the release of various hormones. So what are the question can be asked in the wild. What are the hormones which are released by Sertoli cells? So the answer should be on the tip of your fingers. The answer should be androgen binding protein, estrogen binding protein, inhibin, activin, and Mullerian regression factor. Right? So, and the enzyme here again released is aromatase, which helps in the conversion of androgen into estrogen. So these are the functions of the Sertoli cells. Let's move ahead to next portion, that is the blood-testis barrier. In the central nervous system, we had discussed about triple B, that is blood-brain barrier. So we have got one more barrier, that is blood-testis barrier. So in the exam, please properly read the question and then only answer. Don't write the answer for blood-brain barrier as blood-testis barrier and blood-testis barrier as blood-brain barrier. By just seeing the word barrier in the question, don't get excited. Read the question properly. It can be blood-testis barrier also. Every time it may not be blood-brain barrier. It can be blood-testis barrier also sometimes in the exam. A question has blood-testis barrier. Okay. Now what is this? So blood-testis barrier, it is a mechanical barrier that separates the blood from the seminiferous tubules of the testis. So what is this barrier doing? So this barrier is separating the blood from the direct contact with the seminiferous tubules of the testis. Now how it is formed? It is formed by tight junctions. It is formed by tight junctions. So as it is a barrier, it has to be a tight junction. So it is a tight junction between the adjacent Sertoli cells near the basal membrane of seminiferous tubules. So Sertoli cells, one more thing, they are helping in the formation of barrier. Formation of barrier, that is a blood-testis barrier. Now coming to what are the functions of these blood-testis barrier. So there are two functions. So one is, it is protection of the seminiferous tubules, And the second one is, it is prevention of autoimmune disorders. Prevention of autoimmune disorders. So coming to the first one, that is protection of the seminiferous tubules. The blood-testis barrier, it protects the seminiferous tubules and the spermatogenic cells by preventing the entry of toxic substances from the blood and the fluid of the surrounding tissue into the lumen of seminiferous tubules. So seminiferous tubules are completely protected by this blood-testis barrier, and hence what is going to happen is the toxic substances are prevented from coming in contact with the seminiferous tubules. And the substances which are prevented by this blood-testis barrier are large molecules, which includes the proteins, the polysaccharides and the cytotoxic substances, and medium-sized molecules like galactose. And certain substances are permitted by this blood-testis barrier. So what are those substances? Number one is nutritive substance, because that is very essential for the normal development and the growth of the spermatogenic cells. Second is the hormones. So hormones are definitely necessary for the proper spermatogenesis to occur. So that has to be allowed to enter into the seminiferous tubules. And third one is water. So water is definitely required. So the things which are not allowed are large molecules, including the proteins, polysaccharides and cytotoxic substances, and medium-sized molecules, that is galactose. And what are the things which are allowed to pass through this blood-testis barrier are the nutritive substances for spermatogenic cells, hormones required for spermatogenesis, and the water. Moving ahead to the next function, that is prevention of autoimmune disorders. So not only this blood-testis barrier is providing the protection to the seminiferous tubule, that is a local protection. Second one is autoimmune, it is preventing the autoimmune disorders. So autoimmune is something which will affect the body, right? So this is preventing these autoimmune disorders by inhibiting the movement of the antigenic properties, antigenic products of the spermatogenesis from the testis into the blood. So locally it protected the seminiferous tubules, and now it is going to protect the whole body by preventing the movement of the antigenic products of the spermatogenesis from the testis into the blood. So as a result, this will prevent the autoimmune disorders. Okay. Now there are certain conditions wherein even this barrier can be damaged. How the blood-brain barrier can be sometimes damaged, similarly the blood-testis barrier also can be damaged. So in what conditions? So commonly it can be damaged by any trauma or any viral infections, and the common viral infections which is going to affect this blood-testis barrier is mumps, right, wherein there is orchitis in case of males, right? So what happens? So whenever this blood-testis barrier is damaged, what is going to happen, right? So when this blood-testis barrier is damaged, the sperms which are produced in this seminiferous tubules and they are released into the lumen of the seminiferous tubules, they will enter into the blood. I repeat, if there is damage to this blood-testis barrier, which can occur because of any trauma or because of any viral infection, it enters into the blood. So once it enters into the blood, body will consider these sperms as foreign bodies. So immediately the body's immune system will get activated, and you all know, once the immune system is activated in response to any foreign body which is considered as an antigen, so immediately there is production of antibodies. Though sperm is a product of the same body, it will be considered as an it is considered as a foreign body by the same person's body, and hence antibodies are produced. And as these antibodies are produced, the body's own produced cells, these are called as autoantibodies. These are called as autoantibodies, and these autoantibodies are developed against the sperms, which are the antigens, which are considered antigens by the body. And these antibodies, what they will do, they will destroy not only those sperms, and at the same time they go and they will attack the spermatogenic cells or the germ cells which are present in the seminiferous tubules, and as a result there will be sterility. Hence, this is one of the side effects of mumps. Mumps leads to orchitis. Orchitis, there is damage to the blood-brain, sorry, not blood-brain, it is blood-testis barrier, sorry. It is blood-testis barrier. So once the blood-testis barrier is damaged, the sperms enter into the blood. These sperms, once enter into the blood, activates the immune system. Immune system produces the antibodies, which are considered autoantibodies. They not only destroy the sperms which had entered into the circulation, they also go and they are going to damage the production site of these sperms. That is nothing but the testis. Inside that, again, it is the seminiferous tubules. Inside that, again, it is the spermatogenic cells. So next, coming to the accessory organs of the male reproductive system, that is seminal vesicles. So seminal vesicles, they are again a pair. So they are glands, they are paired glands situated in the lower abdomen on the either side of the prostate gland. So prostate gland is one and seminal vesicles are two in number. So they are present in pair, and these seminal vesicles, they are situated in the lower abdomen on the either side of the prostate gland, behind the bladder, behind the urinary bladder. And what is a seminal vesicle? It is a hollow sac. It is a hollow sac of irregular shape, and it is lined by complexly folded mucous membrane. And the epithelial cells of this mucous membrane of seminal vesicle, they are secretory in nature, and hence they secrete a fluid which is called as seminal fluid, which is one of the main components of the semen. Okay, right. Now, the duct of the seminal vesicle, as these epithelial cells present in the seminal vesicle, they secrete the fluid, that is seminal fluid. So that seminal fluid has to be drained outside, and it is drained outside through the duct of the seminal vesicle. So from each side, from each seminal vesicle, a duct comes outside, and this joins with the ampulla of the vas deferens to form common ejaculatory duct, to form the ejaculatory duct, and thus the seminal fluid is emptied into the ejaculatory ducts, and which finally opens into the urethra. Coming to the last accessory gland of today's class, that is the prostate gland. So prostate gland, it is present only in males. I repeat once again, prostate gland is present only in males. This is one of the gland which might increase in its size as the age progresses. So commonly in India we can see a condition called as benign prostatic hyperplasia at around 50 to 55 years of age. Okay, so never make a mistake of diagnosing benign prostatic hyperplasia in females as prostate is present only in males, because this mistake usually, by mistake, this mistake happens. So to prevent that, please remember prostate is present only in males. Okay. Now coming to this prostate gland, it weighs about 40 grams, and it consists of about 20 to 30 separate glands which open separately into the urethra. And these glands are tubulo-alveolar in nature, and these glands, they are lined by epithelial cells, that is columnar cells. They are columnar cells in nature. And this prostate gland, what it does, it secretes the prostatic fluid, which is again a component of the semen. So by this you can understand semen, which is the final outcome, okay, which is finally ejaculated into the urethra. It contains the sperms from the testis, it contains seminal fluid from the seminal vesicle, and it contains the prostatic fluid from the prostate gland. So your primary organ is also helping, accessory male organs are also secreting to finally form semen, and these prostatic secretions, they are emptied into the prostatic urethra through the prostatic sinuses. So that's all for today's class. So in today's class, what we have done is we have discussed about the functional anatomy of the male reproductive system. So in that we have concentrated more on the primary sex organ or the primary gonad, that is the testis. So I repeat once again, TES, TIS, IS is singular and TES is plural. So there are two words here, testis and testis. TES is plural. So we have discussed about what are the structures present inside the testis. Okay, so we have discussed that there is presence of seminiferous tubules that ends in the reticestis. Reticestis, from there begins vas efferens. Vas efferens, it is going to join together to form the epididymis. So epididymis continues downwards. You got the head, the body and the tail. So the tail portion continues as vas deferens, ascends upwards, enters abdominal cavity through the inguinal canal, goes and joins with the duct of the seminal vesicle of the same side to form ejaculatory duct and drains into the urethra. And you have seen that there are three layers or three coverings of the testis. We got tunica vasculosa, innermost layer, vascular layer, middle layer is albuginea, and the outermost layer is tunica vaginalis, again has two layers, outer parietal and inner visceral layer. Then we have seen what are the things present. We have seen in detail about the lobule of the testis, right? So the lobules of testis are they get formed because of the septula testis, right? Base is directed towards the periphery and the apex of the lobule is directed towards the mediastinum. And then the seminiferous tubules, in detail we have seen about this. And the seminiferous tubules, it is having three layers: outer capsule or tunica propria, then you have got basement membrane on which rests the complex stratified epithelium, which is again made up of two types of cells, spermatogenic cells or germ cells, and second is the Sertoli cells or supporting cells. So we have seen about the spermatogenic cells, then we have seen about the Sertoli cells, and major thing is the functions. So by now you might have already understood and you may be in a position to answer what are the functions. So first it is production, it is giving support, nourishment, secretion of various things, aromatase enzyme, androgen binding protein, estrogen binding protein, activin, inhibin, Mullerian regression factor, which is required for the regression of Mullerian duct during the sex differentiation in fetus. Then we have discussed about the blood-testis barrier, which is providing two things. One is protection to the seminiferous tubules and second is prevention of autoimmune disorders also. And we have seen what happens when this blood-testis barrier is damaged. So there is production of autoantibodies causing destruction of sperms and destruction of the spermatogenic cells in the seminiferous tubules, leading to the infertility or sterility, leading to sterility, more better word. Then we have seen about seminal vesicles and prostate gland. So finally you have understood that semen, which is the final product, ejaculated by the urethra. So that is a combination of sperms which is coming from testis, seminal fluid coming from the seminal vesicles, and the prostatic fluid which is coming from the prostate gland. So that's all for today's class. The questions, expected questions from today's class is, one is we can expect Sertoli cells as a 3 marks question. You can expect functions of Sertoli cells as a 3 marks question. Blood-testis barrier can be a 3 marks question. And prostate gland, it can be a viva question. And semen, it can be a viva question. So that's all for today. So let's wrap it up. Thank you.